Dear friends, in last class we have discussed about inverse trigonometric functions and its problems. In today's class we shall discuss about new chapter integral calculus, that is integrals or integration. That is, in integration, the first concept, indefinite integrals. So what is indefinite integrals? Let y is equal to f of x be a function such that dy by dx is equal to f of x. The function f of x is called the derivative. Or differential coefficient. Differential coefficient of f of x with respect to x. The function f of x itself is called an integral or a primitive. Integral or a primitive. Or an antiderivative of f of x with respect to x. This is denoted by integral of f of x into dx is equal to small f of x. Thus, integral of f of x into dx is equal to f of x. This implies f dash of x is equal to capital F of x. So look here. So once again, let y is equal to f of x be a function such that dy by dx is equal to capital F of x. The function f of x is called the derivative or differential coefficient of f of x with respect to x. This is denoted by, so with respect to x, the function f of x itself is called integral or a primitive or an antiderivative of f of x. This is denoted by integral of f of x into dx is equal to small f of x. Thus, integral f of x into dx is equal to small f of x. This implies f dash f of x, that is differentiate with respect to x, becomes f dash of x is equal to capital F of x. That means derivative of x square is equal to 2x. Thus, integral of 2x into dx is equal to x square. Similarly, d by dx of log x is equal to 1 by x. Thus, integral of 1 by x into dx is equal to log x. Similarly, d by dx of tan inverse x is equal to 1 by 1 plus x square. Thus, integral of 1 by 1 plus x square into dx is equal to tan inverse x. The process of finding a function f of x whose derivative of capital F of x is known as integration or anti-differentiation. That is, also we know that the derivative of a constant, that means d by dx of constant, that is denoted by k, where k is a constant, that is 0 is 0. Thus, d by dx of f of x plus c equals d by dx of capital f of x, sorry, small f of x equals capital F of x. This implies integral of f of x, capital F of x function is equal to small f of x plus c, where c is a constant of integration. The constant c is called a constant of integration. Further, as the constant c is arbitrary, the integral or antiderivative of a function is not unique. The entire class of integral of f of x with respect to x is known as, indefinite integral of f of x with respect to x. Hence, we have integral of capital F of x into dx is equal to f of x plus c. That implies f dash of x equals capital F of x. And symbolically, integral of f of x into dx, comma, function f of x, is called integrand. And this function capital F of x is called the integrand. The variable x is called variable of integration. X is called variable of integration. F of x is called the integrand. Here x is called the variable of integration. The symbol is called integral sign. Integral sign. This symbol is called integral sign. So therefore, what is the definition of integration? Integration is the inverse process of differentiation. Integration is the inverse process of differentiation. Process of differentiation. Integration is the inverse process of differentiation. The next, standard integrals. List of standard integrals. List of standard integrals. List of standard integrals. That is, first one, integral of, the symbol of integral of x to the power of n into dx is equal to x to the power of n plus 1 dividing by n plus 1 plus c. Here n is not equal to minus 1. Second one, integral of 1 into dx or dx is equal to x plus c. Third one, integral of 1 by x into dx is equal to log mod x or log x plus c, where c is a constant of integration. The next, integral of 1 by x square into dx is equal to minus 1 by x plus c. Fifth one, integral of 1 divided by root x into dx is equal to 2 into root x plus c. Integral of 1 divided by x to the power of n into dx is equal to minus 1 divided by n minus 1 into x to the power of n minus 1. So in bracket, n is not equal to 1 plus c. The next, seventh one, integral of e power x into dx is equal to e power x plus c. Integral of a power x into dx is equal to a power x divided by log a plus c. The next integral of sin x, ninth one, integral of sin x into dx is equal to minus cos x plus c. The next integral of cos x, integral of cos x into dx is equal to sin x plus c. Integral of secant square x into dx is equal to tan x plus c. Integral of 12th one, integral of cosecant square x into dx is equal to minus cot x plus c. Integral of secant x into tan x into dx is equal to secant x plus c. Integral of cosecant x into cot x, cosecant x into cot x into dx is equal to minus cosecant x plus c. Integral of 1 divided by root of 1 minus x square into dx is equal to sin inverse x plus c. Integral of 1 divided by root of 1 minus x square into dx is equal to minus cos inverse x plus c. Integral of 1 divided by 1 plus x square into dx is equal to tan inverse x plus c. Integral of 1 divided by 1 plus x square into dx is equal to minus cot inverse x plus c. So these are all formulas, list of integrals, that is standard integrals. So 19th formula, integral of 1 divided by x into root of x square minus 1 into dx is equal to secant inverse x plus c. Integral of 1 divided by x into root of x square minus 1 into dx is equal to minus cosecant inverse x plus c. So these 20 formulas, list of standard integrals. The next concept, properties of indefinite integrals. Properties of indefinite integrals. Indefinite properties of indefinite integrals. The first one, first property, if k is any non-zero constant, k is any non-zero constant, and f of x, capital F of x, is a function, then integral of k into f of x into dx is equal to k into integral of f of x into dx. Integral of constant into function, that is equal to, take outside constant, into integral of f of x into dx. If k is any non-zero constant and f of x is a function, k is a non-zero constant and f of x is a function, this can be written as k into integral of f of x into dx. So property 2, if f1 of x and f2 of x, here two functions, f1 of x and f2 of x are two functions, then integral of f1 of x plus or minus f2 of x into dx is equal to integral of f1 of x into dx plus integral of f2 of x into dx. Sometimes integral of f1 of x plus or minus f2 of x plus or minus f3 of x into dx is equal to integral of f1 of x into dx plus or minus integral of f2 of x into dx plus or minus integral of f3 of x into dx. So these two properties of indefinite integrals. Right now, so we'll go for examples. Find an antiderivative. Antiderivative means integral. Find an antiderivative. Or that is integral. That is antiderivative means integral of the following functions. Of the following functions by the method of inspection. Find an antiderivative of the following functions by the method of inspection or using the method of inspection. That is, first one, example 1, cos 2x. So find the antiderivative of this function by using inspection method. We know that d by dx of sine 2x, derivative of sine 2x with respect to x, that is equal to, so you know formula, sin x formula, cos 2x into d by dx of 2x is 2. So therefore d by dx of sin 2x, cos 2x into 2 can be written as 2 cos 2x. This implies integral, take integral 2 into cos 2x into dx is equal to sin 2x. Taking integration symbol on both sides. So first I am taking integral of 2 cos 2x into dx. Integral into derivative gets cancellation, sin 2x. Again this implies take 2 common, that is a constant integral of cos 2x into dx is equal to sin 2x. Therefore integral of cos 2x into dx is equal to 1 divided by 2 into sin 2x. So therefore an antiderivative of cos 2x is 1 divided by 2 sin 2x. The antiderivative of cos 2x function is 1 by 2 into sin 2x. Similarly, second one, find the antiderivative of the function integral 3x square plus 4x cube. Find the antiderivative of this function or find the integral by the method of inspection. That is, also we know that d by dx of x cube plus x to the power of 4. What is the derivative of x cube? It is, 3x square plus x to the power of 4, 4x cube. This implies taking integral of 3x square plus 4x cube into dx is equal to x cube plus x to the power of 4. Therefore an antiderivative of 3x square plus 4x cube is x cube plus x to the power of 4. So now example 3, 1 by x. Find the antiderivative of the function 1 by x where x is not equal to 0. We know that d by dx of log x, derivative of log x is equal to 1 by x, where x is greater than 0, and d by dx of log of minus x is equal to minus 1 by x into minus 1, that is equal to plus 1 by x, here x less than 0. Combining the above results, so we get d by dx of log of mod x, where x is positive and also negative, x is greater than 0 and also less than 0, that is mod x means plus or minus x, equals 1 by x is not equal to 0, x is not equal to 0. This implies integral of 1 by x into dx is equal to log of mod x. Therefore an antiderivative of 1 by x is log of mod x. Antiderivative of 1 by x is log of mod x. The next one more, find an antiderivative of the function sin 2x. We know that derivative of minus cos 2x, you know that d by dx of cos x is minus sin x, minus into minus becomes plus, that is sin 2x into 2. Therefore d by dx of minus cos 2x is equal to 2 sin 2x. This implies integral of 2 sin 2x into dx is equal to, that is minus cos 2x, Again this implies take constant outside 2 into integral of sine 2x into dx is equal to minus cos 2x. Therefore integral of sine 2x into dx is equal to minus 1 divided by 2 into cos 2x. Therefore an antiderivative of the function sine 2x is minus 1 divided by 2 into cos 2x. So, okay students, stop here. So, we'll continue in next class.